Welcome once again. We have the next question from this case now is question number. We solve question number one. We solve number two, number three. Number three answer is B. Please take note of that. And then the next question on the list now is question number four. Question number four here says if you have a function of x which is equals to 3x plus 2 all raised to the power of 3 minus 5. Please, you have to take note of this condition. Whenever you have x is greater than or equal to 0, what does that mean? So from here, we can actually determine the behavior of this function by taking its derivative and analyzing its sign. From analyzing its signs, then that's when we can actually determine whether it is increasing function or is it decreasing function. I'm very sure the maximum point is not 0. If you look for the maximum point, if you look for the stationary point rather, you can never get 0, 0, and there's no way you can actually end up having a maximum point at 0, 0. It's not possible. So the answer is either option B or option D. Now in this case, I said we can actually determine the behavior of this function by taking its derivative. So let's try the derivative of this function, f prime of x. That is, you apply chain rule in this case. 3 comes down, you know how to do that, times differentiate what you have inside the bracket, and that's 3 plus 0. Right? Repeat everything back. 3x plus 2 raised to the power of 3, then you subtract 1. If I differentiate this 5, I have 0. So trivially, the derivative is 9 open bracket 3x plus 2 all squared. Now, when you look at this, this is the derivative. And whatever you have to do from here now is that since the derivative of this function is always positive, for x is greater than or equal to 0, this is condition given to us. For x greater than or equal to 0, what do you notice? That means x is equal to 0, 1, 2, 3, 4. So if you substitute x equals to 0, 1, 2, 3, 4 in this derivative, no matter how you substitute all these values until you get to infinity, you notice that your f prime of x still remain as what? As positive. It will always remain as positive in this case. Now, trivially speaking, I can actually conclude and say that, okay, the derivative is always positive for x greater than or equal to 0. So therefore, the function is what? Is increasing. So just go ahead and pick option B in this case. So as far you set this condition into this derivative, when x is 1, when x is 0, you are positive. When x is 1, you are positive. When x is 2, you are positive. So if you keep on substituting, you notice that your derivative is positive all through. And if your derivative is positive all through, this is a condition which says that the function is said to be an what? To be an increasing function. So that's very direct. Next question. Question number 5, which says find dy dx if xy plus sin y is equals to 1. This is you have to apply product rule here, which implies u v prime plus vu prime, then plus, if I differentiate sin y, we obviously that's what? That's cos y. But remember to put what? Dy dx in this case. Then if I differentiate 1, that's 0. Now what is my u in this case? U is x. Let this represent u and let this represent v. My u is x. My v prime means differentiate this y. And that's what? That's 1. Remember to put what? Dy dx. Then plus, what is v? V is y. And what is u prime? Differentiate x. That's 1. So whatever you have to find there now is to make dy dx the summate of the formula. Dy dx is there. I have x dy dx plus y, then plus what? Cos y dy dx. So this and this are common. Dy dx is common to these two terms, and I have x plus cos y left, then equals to this y goes to that side, I have minus y. So by the time you divide both sides by the coefficient of this dy dx, you end up having minus y over what? X plus cos y. So that means option B is correct. You see, that's very, very direct. Very, very simple to work with. And at the same time, in this case, for this function, find limit as when x tends to 1. Positive. For positive, I'll consider this one. This is for negative. X less than 1 means you have 0 minus 1. This for negative part, and this for the positive part. So I'm only putting x equals to 1 in this case. X tends to 1. That's 3 times 1 plus 2, and that's 5.